Welcome everyone. This is session number 2 of a 3-part series for Intro to AI Product Management. And this week we're going to focus more on building AI products. So just to start, a little bit about myself, quick background. Spent about 8 years in product, mostly in SaaS, working across digital marketing, e-com, and the content creator economy. Currently a senior product manager over at Clover, and that's where I'm focusing on retail point of sale products. Prior to that, I was at a company called Social Native, and that was a platform that connected brands with content creators. And that's where I helped transform a traditionally managed service over into a more of a self-service platform. And then before that, I was at a company called Neptune Retail Solutions. That was primarily on working on scaling digital promotions for grocery stores. Had about a 6 or 7 product portfolio. And most recently, I've been actively experimenting with AI through side projects on my YouTube channel. You can check it out. It's called Product by Kel, and that's where I document everything that I've learned and I'm still learning about AI. I'm on YouTube, Instagram, TikTok, and you can also check out my portfolio at kelhu.com. All right, so let's go ahead and get started. So before we step into the role of a builder, let's ground ourselves in the mindset shift that we covered in the previous week. Um, we we compared traditional software product management to a train. It's deterministic. It stays on a fixed track, so it follows a very binary if then logic, and it arrives at the same exact spot every time. But AI product management is probabilistic. So that's the whole self-driving car metaphor. It doesn't have tracks, it has sensors. So it makes a best guess based on the environment. It might take a slightly different route if there's traffic, if there's some roads closed, if there's, people crossing the street or an event. But it's going to try to get to the same destination. Last week we were, oops. Last week we were just learning about how to ride in the car. This week we're going to move from being the passenger to being more of the lead engineer of that vehicle. In traditional software, your only job is to make sure the tracks are straight. But in AI product management, you are managing a living, breathing system. So there's another metaphor for this. The model or the LLM, that's going to be your engine. That's the raw power. You have the prompts. Think of that as like your steering instructions and how you guide that power. You have the data pipeline. Think of that as the fuel. And then you have the UX, and that's more of like the dashboard, right? So how does the driver know what's actually happening? And if any one of these shifts, the fuel is low, the steering is loose, the whole car behaves a little bit differently. You can't just fix one bug in isolation. You have to balance the whole system. The other part is managing the connective tissue. So your job as a PM isn't to be the mechanic who builds the engine from scratch. Your job is more of a systems architect. So you're ensuring that the fuel is clean, the steering is calibrated, and the dashboard is clear so the car stays on the road. You are ultimately responsible for the safety and the performance of this whole probabilistic machine. All right, so the post-launch reality. When you ship a feature in traditional software product management, the code is static, the logic is locked for the most part, and unless there's a bug, you continue to monitor, but the bulk of your job is done. I mean, you're still going to monitor after launch, but compared to AI, for AI product management, deployment is actually just the beginning. So if you think back to the Waymo, the self-driving car, when you put that car on the road, it's going to encounter the weather and the traffic that it didn't see originally in the simulator. I mean, it could have saw some of that in the beginning, but you're not going to know what kind of issues and things and experiences that it's going to encounter. As a PM, you can't just walk away. You have to build what's called the learning loop. So now you're monitoring the driver's performance in real time. If the car starts drifting because the fuel, or in this case, the data, is getting old or stale, you're going to be the one that triggers the whole retraining process. So whether that's, feeding it new data, taking out some old data that doesn't really work for this engine, it's all part of kind of like getting everything back on track. You also need to be a detective. So you can't just wait for, customer support to file a ticket, which is considered more explicit feedback. You have to watch the behavior of this AI product that you've built, which is more of the implicit feedback. If the AI makes a suggestion, for example, and the user ignores it 90% of the time, that's considered more of a silent failure. So as a PM, you're not responsible for instrumenting the product so that you are responsible for instrumenting the product so you can hear those silent signals and then start to tell the engine how to improve the platform. And then finally, you have to watch out for what's called model drift. AI models are not going to be set it and forget it. They can become less accurate over time as the world changes. If you don't have a plan for how to update your model, your product's gonna eventually fail. You aren't just a feature manager anymore, you are more of a systems caretaker. You might remember from last week, we had another metaphor where it's the whole Chef Ramsay in the kitchen, the culinary school. We're gonna revisit a little bit of that. There he is. Yeah, so now that we are building a system, let's take a look at the life cycle of how that system comes to life. So here's our Chef Ramsay metaphor again from week 1. In traditional software, the life cycle is a straight line for the most part. I mean, you code it, you test it, you ship it. Any issues that come up, you iterate and you continue to fix bugs. But in AI, it's a loop. It's a whole feedback loop. It's a process of running a restaurant where the menu is always evolving. So first up, let's frame the problem. Before our chef even puts on their apron, we have to ask, okay, does this customer actually want a 5-course meal, or do they just want a quick snack? And as a PM, your first job is to decide, okay, is AI even actually the right tool for what we're trying to build? If a simple deterministic train track solves a problem like a basic calculator, then don't hire a probabilistic chef. Probabilistic meaning the AI chef. AI is expensive, it's unpredictable. So you only want to use it when the problem actually requires some kind of reasoning or creativity. The second is integrated design. This is where the chef, the recipe, the pantry, those kind of all come together. So you don't just write a prompt and walk away, you design the workflow. We're going to continue with this whole metaphor. So we'll talk about the UI. How does the waiter explain the dish to the customer? What happens if the chef runs out of an ingredient? In this case, that corresponds to data. So you're now designing safeguards, or the kitchen rules that ensure that every dish that leaves that kitchen is safe and high quality before it even hits the table. The third point here is really continuous monitoring. So in a restaurant, the chef's job isn't over when the food hits the table. They're watching the plates, they're watching which plates come back, they're observing what people don't eat. In AI, this is your feedback loop. You're constantly monitoring for bad flavors, or what we call hallucinations or bias. If the customers are confused, if you change the recipe, if the food is bland, you might want to update the pantry. So in AI product management, you're never actually done. You're always kind of refining the menu. So we've looked at the life cycle. Now let's talk about the goal. In traditional tech product management, an MVP is the minimum viable product. In AI, we need to shift a little bit to the minimum viable trust. So if you go back to the self-driving car example, it doesn't have to be 100% to be useful. It just needs to be safe enough for that specific environment. And this is how we redefine the MVP, or in this case, the minimum viable trust. Um, First one is, high accuracy does not guarantee user value. Engineers love to brag about, oh, I have a 95% accuracy score. But as a PM, you have to ask, okay, what happens in that other 5%? Going back to the chef example, if your chef is 95% perfect, but accidentally put some poison every other 20th dish, then you're not going to have a product. You have a liability. And as an AI MVP, it's all about finding the right specific use case where the model's current intelligence actually solves a human problem safely. So the second thing is failure modes are expected and planned for. So what does that mean? You're going to have to assume that self-driving car is going to hit a pothole. You have to assume the chef is going to oversalt the soup sometimes. Traditional PMs try to bug fix every single error, whereas AI PMs, instead, we're building safety nets. So we're trying to design the UX where when the AI isn't sure, it asks for help or it asks for humans to step in or provides some kind of disclaimer. So you probably looked at ChatGPT or, asked some other LLMs, and there's always some kind of warning message that says, oh yeah, double check your work. AI might not be completely accurate. And that's another thing where, a lot of the LLMs today, when they provide an answer back, they're also citing the sources. So you can verify yourself. If you remember from week one, it came from, hey, this is the answer, shifting that to, hey, check if I'm correct. All right, so in the next three slides, we're going to take a look at some of the three levers that you can pull to manage this via MVP, which is buying versus building, setting thresholds, and also human in the loop. Before I jump into that, I know that's a lot of information that we just kind of got into right now. I just want to pause right there and see if there's any questions from anyone out there. All right. If not, you can keep going. All right. So one of the first questions your leadership is going to ask is, okay, the whole build versus buy decision. For example, why are we paying OpenAI when we can just build our own LLM? And as a PM, you're going to need a high accountability answer. Think of it this way. Do you want to hire a master chef? You guys remember Iron Chef? That's where I grabbed that image from. But do you want to hire a master chef who already knows how to cook everything? Meaning, pulling from an API? Or do you want to build a whole culinary school from scratch, which would be a custom model? And realistically, in 2026, 90% of AI MVPs should just start with buying, meaning using an existing API to tap into whether it's OpenAI, Gemini, Claude, whatever that LLM is going to be. And that's going to allow you to quickly test out your self-driving car or whatever your MVP logic immediately without having to spend millions on the engine, right? Why reinvent the wheel when it's already there? Once you have something established, then you can kind of tweak the things to make it a little bit more custom. But for the most part, let's go ahead and get that idea started, get it tested. You're just use something already existing in the API. You only move towards building once you've actually proven this core product works and that you need to lower your long-term costs or you need to maybe protect highly sensitive data in your repository. All right, so setting confidence thresholds, and this is where the whole train versus car metaphor gets a little bit more real. So unlike a train on the tracks, self-driving car is always calculating a probability. When it's driving and it's approaching a stop sign, it could think, okay, I'm 85% sure that this is a stop sign. And as the PM, you are the one who's going to decide, what does the product do with that 85%? Do you tell the car to stop? Or do you tell it to alert the human driver to say, hey, is this a stop sign? And it's not really a business decision. It's more of a math problem. And it's really dependent on context of what your product is actually trying to do and basically what industry it's in as well. So if you're building an AI for the chef that recommends recipes, maybe 70% confidence score is fine, right? The risk is low. But if you're building an AI for a bank transfer, you need to be somewhere like 99.9% plus the whole human review to make sure, you're not messing things up. Same thing like if you're trying to build products for the medical field, for example, it could get bad really quickly if our confidence score isn't quite there. So there you have to define, okay, what's the cost of being wrong before you can set your threshold. All right, human in the loop. So in the beginning, your self-driving car shouldn't be driving out alone at night in the rain with the lights off. For example, you need a human in the loop. And this is one of those core PM strategies where it's going to help you ship faster. So even if your chef in training isn't perfect yet, you don't have to wait 6 months for more training. You can ship it now, but you add a step where a human is in the loop to review the AI's output before the customer ever sees it. And the secret is it's not necessarily about safety, it's more about the data. So every time the human fixes the AI's mistake, for example, hey, you need to stop, that was actually a stop sign, you just ran through the stop sign, you're giving the AI more data to learn from and to better improve itself. Over time, you're going to take those corrective notes from the human to make the AI smarter, and then the human will, not need to be as involved. And that will eventually allow you to pull the human out of the loop and then be able to scale the product. All right, so prompting as product design. In week 1, we mentioned that prompts shape behavior. And today we treat those prompts as, production code. I kind of like this design right here, or this image right here. It's just very basic about how to properly construct a prompt. Think of the prompt in our kitchen metaphor as the official recipe for our chef. So if you change, add a pinch of salt, a little MSG, whatever, the whole dish changes. And an AI changing one word in a system prompt can make your self-driving car take a sudden unpredictable left turn. So as a PM, don't just, tinker with prompts in a chat window. You want to treat them as a product service. So that means when you change a prompt, you don't just hit save, you run a regression test, you make sure the new instructions didn't break the old features, and you're moving from more of a guessing game to more of intent design. And then this is just a very watered down example of, the traditional prompt back in the day and how to construct it. The difference between the lazy prompt, it gives the AI a little bit too much freedom. The AI PM prompt sets the guardrails. If you really want more of a consistent product, you have to provide consistent constraints. And this is kind of the level of detail you need to bring to your engineering team. When you're building like a RAG chatbot, for example, you want to set the guardrails so If someone asks a question to the chatbot that's completely out of pocket, you have the safety net to at least come back and say, hey, that question wasn't very nice or something like that. But very dumbed down. I know prompts nowadays are like they can be very extravagant with a whole bunch of different guardrails, but this is just an example of the difference between a lazy prompt and actually putting guardrails in place. All right, so some of the tools AI PMs should be fluent in. This is kind of like an umbrella. There's a ton of tools out there, but I can give you some examples of what's out there today. So, in order to drive your AI tool or your self-driving car, you need to know how the dashboard works. Your toolbox has shifted. So, first, you have to be fluent in LLMs. You need to know the difference between what's a heavy model, like a GPT 5.2 or Claude Sonnet 4.5. There's a new one that just came out not too long ago. That's considered the master chef. Versus a light model where you can call the API, and that could be like very simple tasks like responding to a chat question. That could be considered like a sous chef, which is faster and cheaper. I personally, when I'm building some of my automation AI projects, I like to use Claude HiQ 4.5. I think it's a very capable coding copilot, and it's relatively cheap. You just have to watch, how many screenshots you're sending into it. It does have a limit. So you want to check in from time to time how many tokens you actually have left. And then you want to make sure it exports all the context in case you do need to start a new chat after you run out of tokens, because it gets super annoying once the chat loses all context of what you're trying to build. Second, we have prototyping tools. Back in the old days, we had Figma. Now we have tools like Lovable, Replit, and now Google AI Studio to build these functional prototypes. And I think this has been a game changer for PMs nowadays. You want to make sure that you actually show how the chef is cooking the meal, not just drawing of what you cooked last night. So you're going to learn some more of that and how to build your own portfolio and start your own channel in next week's training session. And then finally, try to dabble in workflow tools. So this is like N8N or Zapier. Think of this as more of like the nervous system. They connect your chef to the pantry, which is the data. And then the waiter is the UI. And as a PM, you are the one kind of mapping out how these tools talk to each other to solve the user's problem. And I'll share a little bit of my experience on this. I never knew how to code. I didn't even think about going into automation. But being able to just start building in public and capturing whether or not it's, I did a good job or I completely fell on my face. I just hit record, and just through that whole experience of failing fast and figuring out how things work, that was probably the fastest way that I was able to learn these tools compared to, just watching a video of someone teaching me how to use it. So yeah. I think that's a lot of what I wanted to cover today. So just a quick recap. Systems thinking. So this week we were moving from just features more to thinking about a whole ecosystem and how do we set guardrails. What are the strategic trade-offs, the whole build versus buy logic. If you're working in AI, PM, product management, you don't want to rebuild a whole LLM. Get started using an existing LLM, whether it's through an API, and just start testing your product, start testing your ideas and get feedback. And then from there, you can decide whether or not you want to build something more custom. And then intent design, right? Making sure that your prompt is solid, making sure you have the right guardrails in place, and also having that feedback loop, right? Deployment is not when you're done. Deployment is actually when you start your AI product feature, and it's going to be a continuous loop. So it's going to seem like it's never going to be done, but that's That's the thing about AI. It's continuously learning. You always have to continuously refine it. Data is going to get stale. So you have to keep beating that. And just to give you a preview of what's in store for next week, we're going to shift over to, okay, how do I actually like get one of these roles? Now I know exactly, at least a good idea of what an AI product manager does. How do I get this process started and really start trying to get these roles? So we're going to cover revamping your brand. So revise your resume, make sure your LinkedIn is solid, start building a portfolio, having your own website, start talking about, what are some accomplishments and how to start, building a brand and a channel and really showing that you can build stuff versus just saying, here's what I built in the past. Um, and then also, how do we source these roles? How do we reach out to hiring managers? As we all know, this job market is extremely tough right now. So being able to stand out and putting forth that extra effort is going to be definitely a game changer. So we're going to cover a lot of stuff that we do here at Product Gym. Um, yeah, I think that's all I have for today. I'll go ahead and open it up to any questions or if there's anything else that folks want to add.
I think we have one question
Nothing?
from Elaine.
There's a
Oh,
question on here.
Yeah.
oh, whoops.
Elaine asked, what are companies doing to protect sensitive data with proliferation of AI vibe coding amongst employees and communities? You want me to take that, Cal?
Yeah, you could take that and I could add a little bit more as well.
All right, give me a second here. Let me see. Actually, let me bring up the participants. Yeah, Elaine, are you there? Give you talk access.
Yes,
Okay, all right. The very straightforward answer is absolutely nothing.
that's what I thought.
Um, yeah,
Well, okay.
okay, okay, so we're gonna be honest because we run a cybersecurity program right now too. Like 16,000 Apple, Google, and Meta passwords were hacked last year by foreign hackers, right? So honestly speaking, like every cybersecurity specialist is basically saying like where data is stored is basically like the party line. So like there is, I think like from what I'm just seeing on the corporate side is there are companies that are obviously trying very hard, uh, but it comes down to who has the most resources. If you're talking about smaller companies, I just don't think they have the financial capacity to do that. If you're talking about like the big juggernaut banks like a JP Morgan, like they have a fortress around them. Cal can go out there and add, but I think it's hard because hackers are also using AI to automate, you know, cyber attacks as well.
Yeah, one thing to add, I think it also depends on the industry that the company is in. I've seen examples where fintech, for example, is pretty stringent on these policies. So, whether it's having software installed where everything you download or send out is getting scanned. There's also limitations of what kind of tools you can do with AI. Like I've seen it where image generation, video generation is completely outlawed for the company. And then, some security teams are pretty quick about, calling you out if you violate any of those policies. So I think it's really dependent. I think it's more so evident in fintech, especially if it's a bigger company where they have the bandwidth to start kind of tracking what folks are doing with AI. But that's kind of what I've seen so far.
Okay. Yeah, it just seems that, and again, just being mindful because it seems like it's, people are just kind of going rogue. with all, which is great, doing the vibe coding, what have you. But I just was in a session earlier today with one of the executives at Microsoft, Nicole Herskowitz. She's the corporate vice president of 365 and Copilot. And she was saying that they actually, the leaders there are tasked, their performance is based on, what are their employees doing with AI? I mean, it's down to that level of tracking as a KPI by the employee, like in a performance review. So I just started to think, well, if you got all these people trying to, jockey to do AI and put it into their work, and you're using a product that, well, their case is Copilot, so they own it. But like you say, if you're using Open AI or any of these other tools that are owned by other companies, it seems like you run the risk of having a data breach.
Yeah, I've seen it where companies only allow you to use one particular LLM, and that's also closed off to not basically save the data
Yeah,
that you feed into it. So,
yeah. I mean, we have a couple of folks in the, that are alumni of the program that are at Verizon. I'm myself at Capital One. We have a multi-million-dollar arrangement with Google. We are on their ecosystem, and for that reason, naturally, we also bought into the Gemini integration, and it's a walled garden essentially, right? And so there's like a ton of work that goes into data shares and who has access to what. Data is all segmented and protected, and so while that doesn't stop somebody from just like writing things on a notebook and doing what they wish with it, right? And so the larger companies are typically are already starting to like establish these partnerships, right? I think Morgan Stanley did either an OpenAI or a Google sort of arrangement as well. Um,
All right, thank you.
no problem.
Any other questions? Got it. I'll go ahead and actually pop over. I'll show y'all right now. Actually, Kelly, can you mind if I share my screen real quick?
yep, go